Welcome to the third part of seventh module, that is security and performance tests with ZAP. Z-A-P. So in consequent previous modules, we have learned testing APIs with Postman and static code analysis with SonarQube, and we talked about test automation with API tests with Postman on the one hand, and with static code analysis with SonarQube on the other hand. So in this part, in the third part of the seventh module, we will discuss how to perform security and penetration tests on a web application using the ZAP tool based on the OWASP recommendations. OWASP. So then we will add to our Postman skills with which we will perform performance tests on APIs also. So applying web security and penetrating tests or penetration testing with ZAP. So today application security must be at the heart of companies' concerns. Indeed, as soon as a web application or website is publicly exposed on the internet, it's a candidate for an attack by malicious persons. In addition, it's important to note that application security is even more important if it is used to store sensitive data such as bank accounts or your personal informations. To address this problem, OWASP, short for web, short for Open Web Application Security Project, OWASP, Open Web Application Security Project, is a worldwide organization that studies application security issues. So the goal of this organization is to publicly highlight the security problems and vulnerabilities that can be encountered in an application system. In addition to this valuable security information, OWASP, that's Open Web Application Security Project, provides recommendations, solutions, and tools for testing and protecting applications. One of the important and useful projects and documents provided by Open Web Application Security Project is the top 10 application security issues. The document is available at www.owasp.org. Let me show you that. owasp.org, and so top 10, let me click back this top 10, OWASP top 10, and here is that. The top 10 web application security risks. There are 3 new categories, so 2021, 4 categories with naming and scoping changes, and some consolidation in the top 10 for 2021. So here are that. This is for by 2021. This is after 2021. This is by 2017, and this is after 2021. So here you can see that each of one. So one of them is will go through the 2021. The first one, the security risk is broken access control. Second one is cryptographic failures, injection, insecure design, security misconfiguration, vulnerable and outdated components, and few more. So those are the 10 security risks, web application security risks. So it's a very detailed with an explanation, examples, and a solution for each security uh, problems and vulnerabilities that can be encountered in an application system. In addition to this valuable security information, OWASP provides recommendations, solutions, and tools for testing and protecting applications. You can see that OWASP. OWASP Foundation, so main translation efforts and sponsors, and here you can see that information about that OWASP Foundation. So we also have we also have in this document another known security flaw, which is cross-site scripting (XSS). So which consists of the executing HTML or malicious JavaScript code on a user's web browser. The challenge for companies The challenge for companies is to be able to automate the security tests of their applications in order to protect them and take steps as quickly as possible when a flaw is discovered. So there are many security and penetration testing tools available in the market. Very complete a list is available on your screen. So among them, like if you want to see the complete list, we can just get into one link. So owasp.org, inside that testing tools. Let me get into that link. Let me show you that also. owasp.org, owasp and testing tools. Yeah. So these are many testing tools. Yeah, out of which widely used tools are OWASP. So SonarCube also we have seen in our previous one. You see that OWASP ZAP, OWASP Web Scrub, and then Spike, Burp Proxy, Odyssey Proxy. Okay, so another tool in the list that's very interesting is ZAP. That's a short for JED Attack Proxy. So, which was developed by the OWASP community. And previously, we have learned about the Sonar Cube in our previous chapter, which allows the analysis of code in order to detect the security vulnerabilities. But that's limited. So now let's see how to use ZAP to perform security tests on our applications, on our web applications. So to understand better and to work better with ZAP, it's better to know the basics of security testing first. So that's what we're going to do here. So software security testing is the process of assessing and testing a system to discover security risks and vulnerabilities of the system and its data. There is no universal terminology, but for our purposes, we define assessments as the analysis and discovery of vulnerabilities without attempting to actually exploit those vulnerabilities. We define testing as the discovery and attempted exploitation of vulnerabilities. So, security testing is often broken out somewhat arbitrarily, somewhat arbitrarily according to either the type of vulnerability being tested or the type of testing being done. So a common breakout is goes like this: a vulnerability assessment, a penetration testing, a runtime testing, and code review. So let's begin with the vulnerability assessment. Vulnerability assessment is nothing but here the system is scanned and analyzed for the security issues. That's what we call it as a vulnerability assessment. Then we have penetration testing. So in the penetration testing or pen testing, the system undergoes analysis and attack from simulated malicious attackers. So that's what we call it as a pen testing or penetration testing. In penetration testing, we'll create an environment, we simulate an environment such as a malicious attackers are attacking your system, and we'll check whether how much they are able to penetrate into our system. That's what we call it as a penetration testing or pen testing. Then we have runtime testing. The system undergoes analysis and security testing for and from an end user. So in runtime testing, so basically an end user uses our application and will analyze and do the security testing from an end user point of view. Then the fourth one is code review. The system code undergoes a detailed review and analysis looking specifically for security vulnerabilities. Now that a risk assessment, which is commonly listed as part of the security testing, it's not included in the list. So that's because a risk assessment is not actually a test, but rather the analysis of the perceived severity of different risks. So and any mitigation steps for those risks. So this complete activity put together are called as the risk assessment. So that's why I did not include that in this security testing types, because that's not the one. Now let's deep dive into the pen testing or penetration testing. So penetration testing or pen testing is carried out as if the tester was a malicious external attacker with the goal of breaking into the system and either stealing data or carrying out some sort of denial of service attack. So pen testing has the advantage of being more accurate because it has fewer false positives. So results that report a vulnerability that isn't actually present, but can be time consuming to run. So pen testing is also used to test defense mechanisms, verify response plans, and confirm security policy adherence. And automated pen testing is an important part of continuous integration validation. It helps to uncover new vulnerabilities as well as regressions for previous vulnerabilities in an environment which quickly changes and for which the development may be highly collaborative and distributed. So, so how does this pen testing works? So what's the process the pen testing follows? Both a manual and automated pen testing are used, often in conjunction, to test everything from servers to networks to devices to endpoints. So this document focuses on the basically this slide focuses on the web application or website pen testing. So pen testing usually follows these three steps. One is explore, attack, report, out of which explore means the tester attempts to learn about system being tested. So this includes trying to determine what software is in use and what endpoints exist, what patches are installed, etc. It also includes searching the site for hidden content, known vulnerabilities, and other indications of weakness. And the second stage in this pen testing is attack. In this, will simulate the tester attempts to exploit the known or suspected vulnerabilities to prove they exist. And the third stage in pen testing is the tester reports back the results of their testing, including the vulnerabilities, how they exploited them, and how difficult the exploits were, and the severity of the exploitation. So and So few more things. So these are the three stages we will simulate in our pen testing process: explore, attack, and report. Then, so in addition to that, pen testing or penetration testing is carried out as if the tester was malicious external attacker. So the pen testing has the advantage of being more accurate, and so the ultimate goal of a pen testing is to search for vulnerabilities so that these vulnerabilities can be addressed. It can also verify the system is not vulnerable to a known class or specific defect, or it in the case of vulnerabilities that have been reported as fixed, so verify that system is no longer vulnerable to the defect. Now let's meet mr.Zap and see how does it work. So JED attack proxy, Zap, JED attack proxy is a free open source penetration testing tool being maintained under the umbrella of the Open Web Application Security Project, OWASP. So Zap is designed specifically for testing web application and is both flexible and extensible. At its core, Zap is what is known as a man in the middle proxy. What do you call it? A Zap. You see that? A Zap, which is the man or woman in the middle proxy. It stands between the tester's browser. This is the tester's browser and the web application. You see that web application, so that it can intercept and inspect messages sent between browser and web application. So our Zap is a middleman between the web browser from where the tester works, and then to the web application. So modify the contents if needed, and then forward those packets on to the destination. So it can be used as a stand-alone application and as a daemon process. So if there is another network proxy already in use, as in many corporate environments, Zap can be configured to connect to that proxy. So Zap provides functionality for a range of skill levels, from developers to testers, new to security testing. So to security testing specialists, Zap has versions for each major OS and Docker, so you're not tied to a single OS. Additional functionality is freely available from variety of add-ons, in the Zap marketplace accessible from within the Zap client. So because Zap is an open source, the source code can be examined to see exactly how the functionality is implemented. So anyone can volunteer to work on Zap, fix bugs and features, and create pull requests to pull fixes into the project. But for now, we will look into the overall system. It begins with the browser. The commands will come from the browser, and then we have the Zap daemon, and after that the Zap daemon instructs to the web application through a network proxy. If you have a network proxy, then the network proxy will get the commands first, and then it will goes to the web application. Okay, so now it's time to install and configure Zap. So for that, we have to get into our Zap OWASP documentation. Here is the Zap documentation from the OWASP, and you can find that link www.zapproxy.org. Okay, so let's get into the download page. Just click on the download page. It will take you to the download Zap page, and inside that you can see a Zap installers for Windows 64 and 32-bit, then a Linux installers and packages, and Mac OS installer. So there are a good amount of Docker images available on the download site listed here. So multi-platform installer builders and unattended mode and release notes. And if you scroll down here, you can see that a multi now here you can see that Docker images available also. So there are different types of Docker images from the stable, bare, quickly, live. So anything can be used. And then here we have Zap weekly. So weekly cross-platform packages. And then you can use this package management tools, package managers. So Linux repos, you can use this for Chocolatey to install this in Windows. Either you can use directly Chocolatey, you can say Choco install Zap, or FlatHub, Homebrew for Homebrew Cask, that's for Mac OS, and Snapcraft. You can use the package management tool also, and then Scoop. Okay, for us, I want it for Windows. So let me scroll up completely. So either I can click on this Windows 64 installer download, and it will begin downloading. Yeah, it started downloading the Zap windows.exe. It's too much, 239 MB. It's gonna take some time. So by the time we will get into the scroll down, and we will see the one more method that's possible. So the another method that we have here is either you can go with the Docker image, but I want to do it for Windows, so I will go for with the Chocolatey. So Chocolatey. So of course you might have installed the Chocolatey by now. So in our previous cases, so that's why. So I'm not going to show you how to install Chocolatey. So I'll directly copy this Choco install Zap, and let's execute this command in our machine, in our local machine. Let me copy this completely. Okay, that's okay. Anyway, let me open Windows PowerShell, run as administrator, then clear the screen first and say Choco install Zap. So it's going to install Zap. So by installing, you accept licenses for the packages. That's okay. So by the time I'll get back, okay, I have to give S. Just say capital Y. Error, the running command stopped because the performance variable error action performance or common parameter is set to stop. Java home isn't set. Ensure you set the environment variable to Java 11 installation. The installation of Java was not successful. Okay, so Java is not available, so that's the reason we are unable to install this. So I thought I have installed Java, so it was there. Okay, I have another version of Java. Okay, let's install the Java. Okay, so that's the issue. So now to install the Java, we need to get into sorry, just to install the Java, we need to get into the Java Oracle, and then so let me click on View Accounts. So I do not have any account signed in. Let me click on Create an account. Yeah, let me scroll down first. Yeah. Okay. Then let me click on Create an account. So verify your email address to use your account. So let me check my email address. So we have sent an email to this, and with a button to verify your email address. Did you receive the email address? Yes, I have received it. Done. All set. Now it's time to log into the Oracle account. So let me give my password. Yeah, so we got logged into this. Let me do this. Okay, so now we can download the respective Java version. So I'm gonna go with Java 11. Yeah, here is that. Java Development Kit 11.0.8 and ARM64 package. I'll go with the Windows, not so 60 x64 installer for 141.4. So let me click on this to download that. So I reviewed and accept the Oracle Technology Network license agreement for Oracle Java SE and click on download. And let's wait until it gets downloaded, and you can see the lot of API responses that I have worked on for Volvo. Okay, just let's go through this Oracle's website. So here you can, oh, nice logo, fantastic with the back with a shadow. And here you could see the Linux version, the latest version, Oracle Java Development Kits 19.0.2. And if you click on here, you'll get the 17.0.6. And Linux, ARM, whereas macOS, ARM and X and Windows will find x64 compressed and x64 installer or x64 MSI installer. So this MSI is one type of extension package manager. Okay, I think it's done. Let me click on downloads and open it. Yeah, and let me get into the hands-on. Yeah, it's ready. Now I have to install Java development into my machine. So do you want to allow this app to make changes to your device? Yes, of course. Yeah. So welcome to the installation wizard for Java SC Development Kit 11.0.18. So install Java in this location C and the program files Java and JDK 11. Absolutely fine. Go ahead and install it in that location. Installation is nothing but fetching files from somewhere else. That's what we are going to do. That's downloading that .exe package and then put it in a specific folder. That's in Windows. Click next step to access tutorials, API documentation, developer guidelines, release notes, and more to help you get started with the JDK. Okay. At this moment, I don't need. Let me close it. Yeah, let's get into the documentation now. So chocolatey. Okay, OWASP. And I'll scroll down a bit. And here, this is what we're going to use. Choco install Zap. Before that, let me get into this. So Java let me paste it and install it. The running command stopped because of preference. Okay. Okay, there is Java home isn't set. Ensure you set this and you run. Okay, let's do one more thing. In spite of this, we will directly install the application from there. So let me say Zap. Let's install it and get the Java home. Yes. So next, accept the agreement. Standard installation. Yeah, everything is fine. And start installing it. Okay, completing the OWASP jet attack proxy setup wizard. Let me click on finish. Yeah, Zap is ready. Let me open, run it as administrator and say S. That's right. Yeah, our OWASP is ready for attack on, yeah. So Windows Defender Firewall has blocked some features of this app. Okay. So Windows Defender Firewall has blocked some features of this Java platform SE binary on all public and private networks. Okay. Hello Java platform. I'll click public networks such as, okay, allow access. You just access just for this. We'll just allow it. Do you want to purchase this Java Zap session? Yes, we want to. Yeah. As I want to persist this session with the name based on the current timestamp, or but I want to specify name as I want to persist this session, but I want to specify the name and location. So this is what I want. I'll click on start. So now what I'm gonna do is I'm gonna give, yeah, a knob, hands on. So session first Zap. And here is our Zap. Welcome to OWASP Zap. Zap is an easy to use integrated penetration testing or pen testing tool. Penetration testing tool for finding vulnerabilities in web applications. If you are new to Zap, then it's best to start with like some of the documentation, going through the documentation. So you have two types: one is automated scan and second one is manual explore, or the third one is learn more. So let's click on this run an automated scan against your application. That's one way. Or you can do the manual explore your application. That's another way. And just to go through everything, just let me click on learn more. And here you would see the documentation. It has a three windows: left window and the right bottom window, and then right pane. Either you can say the left pane, bottom pane, and right pane. And here you could see the clear cut documentation of the Zap. Local getting started guide, desktop user guide, and this. We will look into the getting started guide in the next video. Now let's look into the getting started guide. Let me click on the getting started guide. So let's go through it step by step. So what is there in that? So here you'll see the overview and about the OWASP ZAP, and after that you will see the security testing basics. So what is vulnerability assessment, penetration testing, runtime testing, code review, all that information we have discussed earlier. Then we will find the pen testing process. What's that? It's an explore, attack, and a report. So total three things. So it's a pen testing is a simulation that we have discussed earlier. It's a simulating the system as if a real hacker, a person wants to enter into your premises. So then we'll see the pen testing goals and Zap. So where the Zap comes into the picture, how it protects or how it works in this whole ecosystem. Then we have seen the installation of Zap. So we did not do it in Mac OS or Linux. We did it in our Windows. So then you should see that our file, and then you can see the Zap desktop user interface and more information such as running an automated scan, interpret your test results and exploring that application manually, and finally manually explore and head-up display. So that's what the complete information. After that, you'll find some of the Zap advanced features, and then you can also get into the Zap market and some of the tools that you can use to automate the process. So, example, Zap is an ideal tool to use in automation and supports a range of options such as Docker package scans. You can use that Docker Hub Actions, sorry, GitHub Actions, automation frameworks, API, and daemon mode. If you just want to see what is automation frameworks here, just click on here and let's get into that. Yeah, automation frameworks, we can use these things just to put into the system, so just to automate everything. Okay, and the full set of jobs currently supported by the framework and other add-ons are these: active scan, delay, GraphQL, OpenAPI, report requester, script, soap, spider, ajax. Yeah, that's more. So uh, that's all about our getting started guide. So I would like you to explore getting started guide, and if you want to get into the advanced details of the Zap, you just click on the useful links, and if you want to explore more, you can just explore it. That's all up to you. Now let's get back to the UI of Zap. Yeah. So to get back to the main screen of this pane, let me click on this less than symbol. Okay, so now we are on the main screen and let's explore the UI now. So we haven't named the session. It's just okay, it's an untitled session with the first Zap name. So let's look into the overall user interface of this. We'll begin with menu bar. That's one. It's a menu bar. You can see on the top one, the top header one, this is called menu bar because it's a bar. It's a bar. You see that it's a big bar which consists of a number of items in it. Number of items. So that's why we call it as a menu bar. So menu bar provides access to many of the automated and manual tools. So it consists of a file. So here you can create a new session, and you can open an existing session, or you can go for the recent one, that's mine. And then snapshot session, you can snapshot the session as with certain name. Then you can import the context, export the context, and you can do more things, and you can exit out of this. That's one. And then in edit tab here, you have a Zap mode. So either you can go with the safe mode, protected mode, standard mode, or attack mode. At this moment it's a standard mode. Then we have view. So how do you want to view your whole tabs? So is this the way you want? Show tab and script tab, or show all tabs, hide unpinned tabs, and everything. That's the view. How do you want to view the UI of Zap? And analyze tab. Then we have a report tab. Here we'll get, here you can generate the reports. Then you have a tools, all the tools which are related to the Zap. And then import, export. As the name suggests, it imports the GraphQL schema, or GraphQL schema, or Open API at different kind of files from different places. Export, it will export the message file, response, URLs for context, and more. And online, you can get into that for learning purpose, and different other issues and help. Okay, so that's the first item in this UI. That's the menu bar. Then we have the toolbar. Again, this is a bar which consists of a tools. Then that's why we call it as a toolbar. Toolbar includes buttons. These are all soft buttons which provides easy access to most commonly used features. So if you want to place more, you can place it here. Okay, so here you can see that this is in a standard mode. Let me save it let me change it to the safe mode. The tools has changed. Protected mode, you see that it's the color has been changed to green. Set break on all requests and responses. Now let me change into the stand mode. Then let me change this to the attack mode. Yeah, you see that there is a change here at the bottom. So now let me get back into now let me put it back into the standard mode. Okay, that's the bar, that's the toolbar. The second portion is the second item in this is toolbar, and the third item is tree window. So that's here, you can see that tree window. Tree window displays the sites a tree and the scripts a tree. So here you will get the tree diagram of sites, or else as shifts. So at this moment there is nothing much, but still you can see some information. You can see the context and then sites. So here it consists of a new context. You can create a new context, or you can import a context, or you can export a context. If you click on this plus symbol, it will create a new script. So which script you want to take, active rules or authentication, encode, decode, extender, whichever you want, you can just select it. WebSocket sender, whichever. You see that the new script has been opened. So now let me close this. The new script, I don't want it. And here also, let me close this script console. It's a request one, it's got open. Let me close this one also. Yeah. So then let me go to the quick start. Yeah. So that's what the third item, tree window. Tree window. Then we have workspace window. That's workspace window is at the bottom one. From here to here. So at this moment, this is a welcome page. And after that, this is where we're gonna work. This workspace or workspace window. So this displays requests, responses, and scripts, and allows you to edit them. So that's what it will be here once you close down this. Then we have information window. So information window is at the bottom portion. So this information window, let me show that. Yeah, here, this window, this information window displays details of the automated and manual tools. So all that information, all the details will be displayed here. Sent messages, filtered messages, everything you can see that here. Okay. So new scan, and the bottommost what we have is a footer. Here the bottommost what we have is a footer displays a summary of the alerts found and the status of the main automated tools. Okay, that's what is about the footer. So here it consists of alerts, and this is the main proxy, localhost, current scans, and information, and more information about the current scans. And here you can find the settings, active scan options, and here you should see attack mode or select scan mode, whichever you want, attack scanner mode. So this is a new scan if you want to go, or existing. Okay, that's all about the UI. We have seen the main menu, and then toolbar, menu bar, toolbar, tree, and tree window, workspace window, information window, footer. Okay, while using Zap, you can just click on here help on the menu bar, or you can just say F1 to access the context sensitive help from Zap desktop user guide. It's also available online, but here also you can get it. You can see that active scan, so you can just go through it. Right click menu, proxy scanner, spider, it's context related one. Okay, so params, http sessions or request response. Okay, and Zap also supports a powerful API and command line functionality, both of which are beyond the scope of this video. So that's why I would like you to explore if you want to explore more. So then, enough of looking at the user interface. Now it's time to put all our talk into action. So now let's look into actual activity in this. So let me get into this. So installation and configuration of Zap is done. So now, oh, okay, this is we have seen persisting a session. So anyone you can choose. We have gone with S. I want to persist this session, but I want to specify the name and location. That's what we have done. And after that, UI we have seen. Then we will begin with running an automated scan. Okay, we will do that. We'll run one automated scan, that too to my website. So let me come here. So here, just come to this working dash, oh, working window, and this just click on this automated scan. So now this work pane will be changed to the automated scan. So it's very simple. So the easiest, it's a pretty simple to use this. It's nothing much. We have to just get into this window, and in the URL to attack, you see that in the URL to attack text box, enter the URL of the website, web application you want to attack, then just click on the attack. That's it. It's pretty simple because it's all automated. Okay, so what I'm gonna do is, so I'm getting to my website. Yeah, so you see that. So this is my website. I have designed this website. Let me scroll this slowly. Yeah, okay, and this website I'm gonna attack. I'm just showing it to you. Okay, this is what I'm gonna, okay, I'll attack this website. So just let me copy this link, yeah, and get back to our here and paste it here. So this is the URL I want to attack, and nothing much to do, just read here. So this screen allows you to launch an automated scan against an application. Just enter its URL below and press attack. Please be aware that you should only attack applications that you have been specifically been giving permission to test. Okay, this is my application, that's why I don't want to attack any other websites, so that's why I'm using my personal website to attack. So now attack, just click on attack here. Use a Zap spider. I have selected this, and use a traditional spider as well as a Zap spider. So and then click on Firefox headless. Okay, and whatever you want you can choose. I'll go with the Firefox headless, and I'll click on attack. So attack start getting the responses from my application. You can see that, and then the scanning has been taking place. It is in progress. 82% has been completed. Almost all URLs found. Notes added new. So failed to start or connect to Firefox headless. Is the browser available supported? Okay, yes. So now it's yeah, you can see that current scans, it's a rescanning again. Now let's see what's going to happen this time. The last time it's unable to connect because of the browser that we are using. That's okay. Now let's see that number requests 278, current scans just 2, and it's going on. And here you could see the sent messages. These are all the requests. These are all the sent messages. And here you could see the filtered messages. At this moment there is nothing. Let's wait for that. Let's wait for the things to be completed. So it's by and large going into the each and every directory. Okay, it's using get method, post method, everything. It's by and large entering into the each and every URL of my application which is there in the server. Let's see what's going to happen. Let it go on. Let it go on. So it's scanning each and every item in my web application, each and every item in my web application. Okay, 200. Okay, that means it's responding well. So it's getting a good response. Mode permanently. Okay, something is mode permanently 301. Okay, and something is not found. Okay, let's wait for that. It's 18% and it's going on. So 978, 988. So a lot of numbers has been requested. So 1000, more than 1000 requests has been sent to that application, and it's fetching each and everything, each and every item of that, each and every item in that application. So Zap is proceeded to crawl the web application with its spider and passively scan each page it finds. Then Zap will use the active scanner to attack all of the discovered pages, functionalities, and parameters. So Zap provides two spiders for crawling web applications. We can use either or both of them from the screen. So we have used both. One is use traditional spider, and second one is a Zap spider. So the traditional Zap spider, here you can see that the top one, the traditional Zap spider, which discovers links by examining the HTML in responses from the web application. So this spider is fast, but it's not always effective when exploring an Ajax web application that generates links using JavaScript. So that's the reason for Ajax 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 applications. JAP's Ajax Spider is likely to be more effective. This spider explores the web application by invoking browsers, which then follow the links that have been generated. The Ajax spider is slower than the traditional spider and requires additional configuration for use a headless environment. Firefox headless we have gone. So Zap will passively scan all of the requests and responses proxied through it. So far, Zap has only carried out the passive scans of our web application. If you see all our passive scans. So passive scan does not change responses in any way and is considered safe. Scanning is also performed in a background thread to not slow down exploration. So passive scanning is good at finding some vulnerabilities and as a way to get a feel for basic security state of web application and locate where more investigation may be warranted. And other type is active scan. You can see that this one on the screen. An active scan, however, attempts to find other vulnerabilities by using known attacks against the selected targets. Active scanning is a real attack on those targets and can put the targets at risk. So do not use active scanning against targets you do not have a permission to test. So that's the reason I'm requesting, if you do not have your own website, you can use some sample websites to target, but don't use that active target. In spite of that, use a passive target. Okay, it's a humble request to everybody whoever is doing this targeting. Okay, don't target a website which you do not have a permission to test it. Okay, it's pretty important point from my side, you to be noted. So it's completed, the attack complete. You can see that and some information here. Server leaks version information. You see that after attacking it, we got to know that server leaks version information via server HTTP response header field. So risk is low, though the risk is low. And here you can see that evidence is this. So Apache and Apache 2 is the version that we have used, that I have used to serve this application, and then Ubuntu is the one I have used it. And here is the one that is leaked. Okay, if you have a doubt, I am going to show you that also. And see, this is the server that I used. Okay, let me scroll down. AMI platform is Ubuntu. AMI image ID, and if you want AMI name Ubuntu image as HVM SSD Ubuntu Bionic. So that's it. Hence proved, just using a Zap you can target the application and you'll get to know the problems, you'll get to know the vulnerabilities and security threats. So server leaks a version information in this case. So that's how you can find out. Of course, the source is, this is passive. This is not active one. The passive one, 10036 HTTP server response header. In that we got this. So description, the web application server is leaking version information via the server HTTP response header. Access to such information may facilitate attackers identifying other vulnerabilities. Your web application server is subject to different kind of things. Let me scroll down. So now what's the, how to solve that? Okay, before we see that, before we look into the problem and the solution, so what we are going to do is how to interpret your test results. That's the next question. How to interpret your test results. As Zap spiders, your web application, either one, the crawler, either you can use a traditional spider or Ajax spider. That's what the spider, that's what the crawler we used to crawl across the web application. So it constructs a map of your web applications pages. Let me show that the map. Let me click on select, and here you should see the complete, this is the site. Inside that you can see the all the items. Okay, you see that from top. Let me, yeah, this is the site. Inside the sites, this is one site I have attacked, and on that site, and here you can see that information. Okay, all the information, everything, whatever is there in that, exactly you can see that. From CSS code, download, icons, image, JavaScript, lib, and more and more and more. Okay, let me close this. So these, then here you can see that tree diagram. Let me click on, you see that it's orange flag. But before we get into that, first you see the tree diagram. Then it records the requests and responses sent to each page. I'll show you that. These are the requests that are sent, and these are the response that we got. Request get HTTP. This is my website URL, and this is the HTTP 1.1 version, and host is this, my subdomain name, and then domain name, then user agent Mozilla, that's what the agent it has used. Yeah, this is the request, and this is what the response we got. You see that in response you can clearly see in header response, first one is fine, no issue, then this is the date, no issue, then the server information, you see that it's giving server information. That should not be the case. And after that, e tag accept ranges content length Encoding, all those are all those are fine. And here you can see that a complete code itself, we got it. Complete code. Yeah, complete source code of my web application. But that's fine. So now let's see explored pages. This is the history, alerts, and active scan. These are the active scan pages. These are the explored pages. Let me scroll up, scroll up, scroll up. And we can see the each page request and a response. Let me completely scroll up to the top. Yeah. So this is the first page. It scrolled. It crawled, and the request you can see for this page. Okay, this is the request of that portfolio 2.jpg. That's the request, and the response you got. You see that? You can see that image itself. That's the response we got. Yeah. Okay. Let me see that. So, uh, to examine a tree view of the explored pages, click the Sites tab here. This is the Sites tab. In the tree window, you can expand the nodes to see the individual URLs accessed. Let me click on that. You see that individual URLs accessed. First one is get forward slash, second one is get CSS, then get download, then get image, get JS, get lib, and last one is get robots.txt and get sitemap.xml. These are the different individual URLs which are used by our Zap. So now we'll just look into the alerts type. So we'll view into the alerts and alert detail. So if you see the left hand side of the footer, you see that this portion exactly at the bottom. Focus on the bottom, leftmost bottom here. So the left hand side of the footer contains a count of the alerts found during our test, broken out into risk category. These risk categories are: first one is high, second one is medium, and third one is yellow, light yellow. It's low. Then the fourth one is informational. Then fifth one we do not have here. The another one we have is a false positive. At this moment we do not have, but normally we'll have a false positive also. So out of my all alerts, I got 0 high priority alerts, 6 medium priority alerts, and 3 low priority alerts, and 4 informational priority alerts. Okay. So to view the alerts created during our test, just click the alerts tab. Let me click alerts tab. Here you can see that alerts tab. Now in the information window, this is our information window. In this information window, you'll find the alerts tab. Then click each alert displayed. So these are the alerts that were found, and here you can see the total 13 alerts. 6 plus 4 plus 3, 13. So now let me see, you can see that's all alerts here. Now click on each alert displayed in that window to display the URL and the vulnerability detected in the right side of the information window. Let us begin with the absence of anti-CSRF tokens. And here you can see that this is the URL, and risk is medium, confidence is low, not that issue. CWE and WASC ID you can find out there. And this is passive. And here is the description. What's the description of this? No anti-CSRF tokens were found in a HTML submission form. So this is a submission form that I have attached at the bottom. Let me show that. Yeah, this HTML submission form it's talking about. And this is my portfolio: GitHub, Docker Hub, HackerRank, YouTube. Okay, this that's what it's talking about. So Yeah, and here you can see that form also. Exactly, you see that form, the form tag. Not then. So this makes a cross-site request forgery is an attack that involves forcing a victim to send an HTTP request to a target destination without their knowledge or intent in order to perform an action as the victim. So the underlying cause is the application functionality using predictable URL or form actions in a repeatable way. The nature of the attack is that CSRF exploits the trust that a website has for a user. By contrast, cross-site scripting. So other information, if you want to see here, you can see that more information. Then what's the solution for that? That's the next question that arises. The solution for this is phase is architecture. Where you need to solve this, you need to solve this at the architecture and design. When you're designing your application, use a vetted library or a framework that does not allow this weakness to occur or provides constructs that make this weakness easier to avoid. For example, use anti CSRF packages such as the OWASP CSRF guard. Of course, CSRF is pitching about their product. That's, don't take it that seriously. Let them do. So, if you want to see references, and here you can go into the references to find out the more information about that. And down, alert tags. These are the alert tags key and their values. And similarly, we have few more here. So at the same time, the second alert that we have here is again, this is also medium type. You can see that it's a medium type, and what it's saying, it's application error disclosure. This page, the problem here is this page contains an error or warning message that may disclose sensitive information like the location of the file that produced the unhandled exception. So this information can be used to launch the further attacks against the web application. So the alert could be false positive if the error message is found inside the documentation page. So there is a big issue here. So how to solve this? Review the source code of this page, implement custom error messages, consider implementing a mechanism to provide a unique error reference or identifier to the client, so while logging the details on the server side and not exposing them to the user. That's the fantastic. At least you have to provide some login so that it won't be exposed to the external environment or to the hackers. So now, after clicking this alert, you can look into the workspace window here, the workspace window. Click the response on this. Let me click on the response. Yeah, now to see the contents of the header and the body of the response, the part of the response that generated the alert will be highlighted. And here is the parent directory. This is where the problem came. Now let me select the one more thing, and here the issue is content security policy, and let me click on response, and this is where the issue. Now directory browsing, and here is the parent directory. That's where the issue. Then directory browsing another, and here is the title. It's the issue is at the title index of /css only. That's Apache 2. It's possible to view a listing of the directory contents. Okay, other people can see the directory content only directly. So there are a lot of issues with that. A lot of issues. Then we have content type header is missing in this. This is one more issue. So it's informational. It is not that serious. Okay. The solution is ensure each page is setting the specific and appropriate content type value for the content being delivered. Okay, that's the informational one. Okay, and server leaks version. This is very important. So okay, this is very important. Let me get it here. So here you see that this is the problem, Apache /2.4.29. That's the server, and that service we have installed in our server, and that's been leaked. So this is pretty low. That's okay. But the issue here is, it's important one. The web application server is leaking version information. You see that server HTTP response header, it's leaking this version information 2.4.9. Access to such information may facilitate attackers identifying other vulnerabilities. Your web application server is subject to various vulnerabilities. Okay, so solution: ensure that your web server, application server, or load balancer, etc., is configured to suppress the server header to provide generic details. That server header, it should be suppressed. So the server header should not be shown at any cost. So that kind of a solution that kind of solution we have to take, that kind of action we have to take. Okay, so that's all about the various alerts and information, and the request response, and then let me click on the response, and these are the alerts, and these are the different types of alerts. And the spider, this is the spider, it's a manual. This one is a traditional spider which crawled across our website, and the other side we have a Ajax spider, which is the latest one, which can, if it is a Java based web application. And here is the alerts, and if you click on the history, you can find the history information, and even at each URL you can find out the problem. Okay, what kind of alert, what kind of flag has been raised at the each URL in the tree diagram. You can see that everywhere you can find out, either you see that in each and every image. Okay, this is what the issue with this image. So, and see, spider has crawled each and every one, each and everything in that. That's what the tree diagram, that's what the tree diagram. And that's how we scan, we attack, and we find out the vulnerabilities. This is automated scan. Now let's explore an web application manually. The passive scanning and automated attack functionality is a great way to begin a vulnerability assessment of your web application. But it has some limitations. Among them are: any pages protected by a login page are not discoverable during a passive scan, because unless you have configured Zap's authentication functionality, Zap will not handle the required authentication. So you don't have a lot of control over the sequence of exploration in a passive scan or the types of attacks carried out in an automated attack. So Zap does provide many additional options for exploration and attacks outside of passive scanning. So spiders are a great way to explore your basic site, but they should be combined with manual exploration to be more effective. Spiders, for example, will only enter basic default data into forms in your web application, but a user can enter more relevant information, which can in turn expose more of the web application to Zap. This is especially true with things like registration forms where a valid email address is required. The spider may enter a random string which will cause an error. That's what had happened in our previous example. Also, a user will be able to react to that error and supply a correct formatted string, which may cause more of the application to be exposed when the form is submitted and accepted. You should explore all of your web application with a browser proxying through Zap. You do this Zap passively by we do this Zap passively scans all the requests and responses made during our exploration for vulnerabilities, continues to build the site tree, and records alerts for potential vulnerabilities found during the exploration. It's important to have Zap explore each page of our web application, whether linked to another page or not. For vulnerabilities, obscurity is not security, and hidden pages sometimes go live without warning or notice. So be as thorough as you can when exploring your site. You can quickly and easily launch browsers that are pre-configured to proxy through Zap via the Quick Start tab if you want. So browsers launched in this way will ignore any certificate validation warnings that would otherwise be reported. So the conclusion of this slide is, if you want to have an effective scanning, it's better to go with the manual exploration. That's it, nothing much. So to manually explore our application, we need to follow a step. Let me show you that. To manually explore our application, the first step, start Zap and click the Quick Start tab of the workspace window. Then click the large Manual Explore button in the URL to explore text in the URL to explore to text box. Enter the full URL of the web application that you want to explore. From now onwards, it's similar. Then select the browser you would like to use. Then click the launch browser. Let's do that. Let's do this. So this is the quick start. Let me get back to the main screen. And here you could see the automated scan and manual explore. Last time we did the automated scan. Now I'm going to click on manual explore. Then I'm going to give my website a link here. Just copy this and get back to our and paste it here. Then select the browser that you would like to use. For that we have to launch the browser. So let me launch the browser. So the provided browser was not found. We're facing problems with Chrome. So let's get into the Mozilla Firefox and install. Just download the Firefox browser and install it. So let me download this. Okay. So once the download is done, just install it. So just click on this installer and then install it. Okay. Once installation is done, then you just get back to the work. Because I have installed it, so you also install it. It's not a big deal of installing. Okay. So now let me take my IP and paste it here. So then click on launch browser. So change it to the Firefox and then click on the launch browser. And I have also attached the HUD. So what is HUD? You see that the complete website itself is visible now. The welcome to the Zap HUD is also visible. So let me take you through the HUD and then we'll get back to this work. Okay, it's clear. So Zap to manually explore our application is done. Then once you then we will look into the what is HUD, the heads up display. Okay, this is what the HUD, the heads up display. The heads up display is a new and innovative interface that provides access to Zap functionality directly in the browser. It is ideal for people new to web security and also allows experienced penetration testers to focus on an application functionality while providing key security information and functionality. That you can see. I'll show you that just a minute. So let me get into that Zap. Yeah, nope, browser, and here is that Zap. So now the HUD is overlaid on top of the target application. So this is the target application, the behind. and on top of that this HUD has been overlaid in our browser when enabled via the manual explore. That's what we have done on toolbar option. So only modern browsers such as Firefox and Chrome are supported. Of course, I have faced some issue with my Firefox. So Firefox users may need to disable enhanced tracking protection in order to able to see the HUD interface. I have done it. If you want, you also have to do that. Okay. So where you can find this this can be done by clicking on the shield icon in the URL bar. You see that? Just click on this and enhanced tracking protection is on for this site. Enable tracking protection. So this one you can just put it off. So keep your data to yourself. Just put this off, and enhanced tracking protection is on for this site. Just put it off if you want. Okay. So I just put this off. So now in order to be able to see the HUD, so this can be done by clicking. Okay, by default a splash screen is shown. HUD includes. Okay, let me recreate it. Let me relaunch it. Launch the web browser. Yeah. So now you can see the flash screen on the top of our web application. So basically this includes a link to a tutorial which will take you through the HUD features and explain how you can use it. So let me click on take the HUD tutorial, and here is that on the another page. So don't show the screen here. So the HUD is completely new way to interact with Zap. So what is that new way? So it overlays security information on top of the application. So that's how it works. So index, and then next we'll go to the next. So obligatory warning, Zap is a security tool, and therefore by design you can use it to attack web applications. So you should only use Zap, you should only use Zap on applications that you either own or have permission to attack. Okay, you should be that should be very clear on your mind. The good news that if you installed Zap on your own machine, then you do own this tutorial. So let's get started. Okay, so let me leave this. Yeah, this is what, and browser is under remote control. Okay, and this is our node tracker, and you have added a security expectation for the site. Okay, and here you can see that completes. So out of scope, off break, 0, and you can clearly see page alerts media. So 3 of medium size, the medium level, low level are 3, and alert info is 1. And some of them before we got huge, now some of them got removed because uh, this is what the actual some of the passive one has been removed. So these are the active ones, some of the passive ones has been removed. And similarly, this is the site tree. If you want to see site tree, you just click on here and click on the plus symbol, and here is that you can clearly get the complete information. You see that every page, and you can click on each. So that's all the methods you can get it, what all methods are used on sub. Okay, everything you can get it. Let me close this and start. So this is not in scope. That's okay. And in order to spider the sites, you must add it to the scope. Add this to the scope. Start spidering it. So now it started spidering it. Let's wait for that. Then this is a Zach spider. So we don't want this now. Active scan start. So start active scan. So this is what the active scan, the previous one is passive. Now the active scan is also been started here. Then attack mode, let me put this in attack mode. Let me turn this on. This will cause Zap to automatically attack all pages in scope. So let me turn this on. So now I have put it on attack mode. So site high alerts are 0, medium alerts are 3, low alerts are 3, and site alerts info are 2. And this is the additional button. So that's what the HUD way of doing. So you can see your application, whatever, for example, I've clicked and each function can be tested. You see that? So this is a download option for my resume, and that also can be seen here. Let me go back. So each and everything in this way, each and every functionality can be tested. Each and every functionality. I just want to check this. Now see, after opening that, there is one more. Okay, let me click on this. So total how many? High site alerts are 0. Medium we have, okay, absence of okay, this link. And directory browsing we have 2. Low we have this many. Informational we have this many. Now what I'll do, I'll try to access my YouTube channel from here, and let's see what's gonna happen. Okay, so I don't find any changes in this. That means it's absolutely fine. Okay, and let me move from here to external link and see what's gonna happen. Okay, yeah, so there is not much of change, so that means it's absolutely fine. So that's how we use manual exploring an application manually. That's how we explore the web application manually. So now let's wrap up the part 3 of module 7, which is security and performance stats using Zap. Okay, so here so far we have seen applying web security and penetration testing with Zap. Then security, what all tools that are available for the security and penetration testing. Then we have understood some basics of security testing. Then we looked into what is a pen testing or penetration testing. Then we understood the pen testing process, such as explore, attack, report. Then what's the main pen testing goal? Then we first met the Zap JED attack proxy. How does it help us in handling this security and vulnerability issues? Then we have installed and configured the Zap. Then we started with Zap and we looked into the Zap desktop user interface. Then we have run an automated scan. Then after that we have run an manual scan. We have seen the difference between the automatic scan and then automated scan and then manual exploration. And we wrap this up. So the final and my one more the final suggestion that I'm gonna give, and I would request you to use only the website you have a permission to use, or your website. That's it. Don't use any random websites and don't attack that website using this method. Okay, I'm literally requesting you and urging you to don't use random website and attack on it. Okay, that's not safe. That's not safe for you and safe for them. Okay, and that's not the right way of doing the things. Okay, then I'll see you on next module. That's our mega projects. We'll have lots of fun there. Literally, the fun is loading.